Okay, 8.4, Laws of Logarithms. All right, so we have a bunch of properties here. Some keywords, so we already did this one. Okay, log x divided by log b. Okay, we have this rule here, log x or log b. If you do the switch, do the inverse of reciprocal, you can switch the values here. Some key ones here I need you to know. If you have a log b base b, it's just whatever the exponent is, x is equal to x. This one, you can't really see it, but it's b to the power of log base bx. So what happens, these cancel out as well and equals x. I'll show you with some examples. Okay, the key ones we're going to work on today is the product law. Okay, so two ways. So if you have logs with the same base and you're adding them, you multiply the m and n together. Likewise, if you're subtracting, you divide. And if you have a power here, you can move this n to the front. We did that in 8.3. Okay, so I'm going to go through some examples and show you the different rules or laws. Okay, so first, log base 8.4 plus log 8 base 16. So here we have two logs with the same base, both are 8s. So what we can do is bring them together and multiply the 4 and the 6 together. So we have log base 8 and then 4 times 16. So that gives you log 8, 64. Actually, I don't need the bracket anymore. 4 times 16 is 64. Now you can plug this into your calculator, or you can think about it. 8 to the power what will give you 64? And that answer would be 2. Okay, next one. Again, same base, log base 2 here. We are subtracting in between, so we divide the numbers. So log base 2, then we have 48 divided by 3. So when you divide the numbers, you get 16. So 2 to the power what will give you 16, or plug it in your calculator, log 16 divided by log 2. So 2, 4, 8, 16. So the answer should be 4. Okay, next one. So at the base we have a number, we have the exponent. So what we're going to do here is now bring the exponent to the front, because we're allowed to bring the exponent when you have a log. So we get 5 log base 2, 4. Now, remember I told you when you make it to the front, we now have multiplication. So we're going to solve this here. So you've divided log 4 divided by log 2 will give you the answer of 2. So 5 times 2 gives you 10. All right, now kicking up a notch, throwing some radicals in here. So we have the third root of 25. So what we're going to do is convert that root or the radical into an exponent. So if you recall from grade 11, when you put the radical in the exponent, it becomes a fraction. So we're just going to switch it. So log base 5, 25, and now we're going to put the root as a fraction. Okay, so this root of 3, or the cubic root, becomes 1 over 3 in the exponent. Now we have it in the exponent, then we have a log, we can bring it to the front. So we have log, 1 over 3 log base 5 times or to 25. So log 25 divided by 5 is 2. So we have 1 over 3 times 2. And 1/3 times 2 is just 2 over 3. By the way, if this was a square root, the fraction would be 1 over 2. If this was 4th root, it'd be 1 over 4. 5th root, 1 over 5, and so on. Okay, next one. Again, bring our exponent to the front. Remember, if there isn't a base written, it is automatically a 10. So we have 2 log base 10, so 1.001. Divide that out. And you get the answer of -3. So we have 2 times -3, which is, so we just did this, is -3. And that gives you -6. All right, another one. Okay, so same thing here. I'm going to change the radicals. So I'm going to change the square root into 1 over 2. So square root is the same as 1 over 2 in the exponent. I'm just going to do this an extra step to the power of 3 plus log x squared minus log x now to the 1/2. Now I'm going to simplify this. When you have a power of a power, going back to grade 9, we multiply those. So 1/2 of 3 is 3 over 2 plus log x squared minus log x 1 over 2. Okay, now we're going to try to simplify this. So we're adding logs and subtracting logs. They all have the same base, which is 10, so base 10 for each of them. So we're going to add, so we're going to multiply the 3 over 2 times x squared minus, hold on a second. Okay, so here, log base 10. So we're going to have x 3 over 2 times x squared divided by x 1 over 2. Okay, this one was a little bit different than the previous ones because the previous ones, this was a number. So we needed to multiply or divide those numbers. But now we have an x and exponent, so we have to multiply and divide the x and the exponents. Okay, so what happens here, when you're multiplying the same bases, you add the exponents. So we're going to add, so this is 2 over 1. So 3 over 2 plus 2 over 1, common denominator would be 2, so it would be 3 over 2 plus 4 over 2. So 3 over 2 plus 4 over 2 is 7 over 2. Now we're going to divide by the 1/2. Oh, I don't know why I wrote the 10 here. I didn't need to write the 10. Now when we're dividing, we have like terms. Okay, so we deal with the exponents. When you divide an exponent, you subtract. So 7 over 2 minus 1/2, 7 over 2 minus 1 over 2 becomes 6 over 2. And the last step, 6 over 2 is the same as 3. Okay, I just want to double check my answers here. This was F. Yes. Okay, so again, convert the radical into exponent, so the root becomes 1/2 on both of these. This already had a power of 3, so 3 times 1/2 would be 1.5, or, sorry, 1.5, or 3 over 2. Now we're adding here, so we multiply the x to the power of 3 over 2 and the x squared, and then we subtract, so we're dividing the x to 1/2. When you multiply these, you add the exponents. So 3 over 2 plus 2, or which is 3 over 2 plus 4 over 2. Because you have to make a common denominator, so you get 7 over 2. Now we divide by a half. When we divide exponents, we subtract. So 7 over 2 minus 1 over 2 is 6 over 2. And once you simplify the 6 over 2, you get 3. Okay, now our last one. Okay, so for this one, I'm going to go the opposite way, and I'm going to bring the number in the front to the exponent. We probably could have done that to other ones. This one we could have solved it, but I didn't. Likewise, this one here, I could have just did 4 to the power of 5, 4 to the power of 5, and then do log of whatever that answer is divided by log 2. So here, I'm going to keep the log x on the left side, you'll see why. So I get log 4 to the power 2 plus log 3 to the power of 3. So log 16 plus log 9. We're adding the same base, so the same base because they're both base 10. So then we're adding, so we're going to multiply them. So 16 times 9. 144. Okay, so there's a rule here. So your answer is just going to be x equals 144. So you can cross off these logs, and your answer is x equals 144. Okay, I'm going to show you where that rule is in a second. Oh shoot, I did something wrong. 3 to the power of 3 is not 9, it is 27. So that makes this 16, 42, 4, 12, 16, 0, 7, 2, 32, 3, 432. My apologies. So the rule that we used, I'll show you above, is this one right here. When you have the same bases on both sides, so on one side of the equal sign is a log base b, and on the right side is log base b, they have two numbers here, or in this case 2 letters, so it's just x equals y. So you can cancel these out and you get x equals y. So likewise we get here. So we have log base 10 on both sides, we cross them off, so it's just x equals 432. Okay, I'm just going to double check the homework. So the homework is, I think that's here, 1 to 15 ACE, all of them omit these 3 questions, you do not need to do them. And that is 8.4, and that is the last lesson for logs this week. We'll continue with the last 3 sections or lessons next week for you guys. Okay, so you have Thursday and Friday to complete this.